Let's go ahead and talk a little bit about electricity. Now, if we were to classify electricity into two parts, we would have static electricity A and B current electricity. Static electricity is the study of charges at rest. And so basically, as the name suggests, it's the type of electricity where you don't have a flow of electrons, you don't have a flow of charges, unlike current, which is actually a flow of charges or electrons. In static electricity, we mostly have things that are insulators that are associated with static electricity, things like wood or plastic, whereas current electricity is mostly associated with things that are conductors, such as water or metal, and obviously different types of metals like iron and copper. Now, one of the main examples that is used for static electricity to kind of signify how it works is the study of induced charges and how things gain negative or positive charges. Of course, we know that materials cannot really gain positive charges because the protons are inside the nucleus of an atom, and in order to break open the atom, we need a lot of energy. And once that atom is broken open, it actually can release a lot of its own binding energy. So protons cannot be transferred between atom to atom, but only the electrons which are in outside shells that kind of orbit the atom can. And so that's one of the main basic things that we need to know about the transfer of charges. Now, let's say we have a perspex rod, and this type of specific material is rubbed with a piece of dry cloth. So here we have a piece of dry cloth. As this material is rubbed on the perspex rod, it gains negative charges. And basically the electrons of the perspex are transferred to the dry cloth. It turns out that anything that loses electrons becomes positively charged, so the perspex becomes positive, and anything that gains electrons or negative charges becomes negatively charged. And that kind of makes sense. Anything that essentially has an influx, has a more negative charges, is negatively charged, whereas anything that has more positive charges, like the perspex in this scenario, becomes positively charged. Now, let's go ahead and take a look at some parts of current electricity, specifically what exactly is current, what exactly is a voltage, and things of that nature. Now, in order to understand the concept of voltage, there is two analogies you can look at. But one of the easiest ones to actually consider is to imagine you have a simple circuit. In this simple circuit, there is a bunch of working guys. So this lamp is actually connected to a battery. And in the battery, that is actually the symbol for a cell. So let's make that into a battery. So a battery consists of two cells. So let's say the electrons are a bunch of working guys with backpacks full of energy. Now these working guys, they come out of the battery, they're all happy, they're just living their lives. Now as they come out, their backpacks are full of energy. They go through the circuit and they reach the greedy lamp. The lamp takes away their energy, and in return it gives off a bit of light as well as heat. So light is given plus a little bit of heat. We know that heat is existent, that's why when we touch the lamp it feels hot. But when the guys come out of the other end of the lamp, they've used up their energy in their backpacks, so that they're now sad and they don't have any more energy. So the story goes on, and they go back to the battery until they're refueled and they're happy again. And this process goes on until the battery runs out of its chemical constituents to really feed the electrons to have their energy. So what exactly is voltage in this scenario? Well, you can think about the energy in their backpack as voltage, whereas the number of these people that pass through a given point as current. So the energy in their backpack is just like a voltage, and the number of them that pass through a given point is just like current. So voltage, or potential difference, is simply the amount of energy carried by each coulomb of charge. Now, the symbol used to show voltage is V, but V is also used as the unit of voltage. That's why sometimes we use potential difference or PD. Now you can calculate the exact amount of energy in their backpacks by using the equation energy is equal to voltage times the charge. In this equation, Q is obviously the charge. V is the voltage, which is measured in volts. Charge is measured in coulombs. And E is the energy that they have measured in joules. Now, if I were to calculate the exact number of these blue people, or these electrons per se, that pass through a specific point per second, I would be calculating the electrical current. So current is simply the flow of charge, or the flow of electrons. Now, current is denoted by the electrical symbol I, and the unit of current is actually ampere, which is denoted with a capital letter A. Now, in order to calculate the exact amount of current in a circuit, you would have to actually divide the amount of charge that passes through per second, so per unit of time. So Q over T would be giving you the electrical current, where Q is the electrical charge measured in coulombs, and T is the time measured in seconds. So basically, you could say that the unit of electrical current, another unit for it would be coulombs per second, or just 1 ampere. So 1 ampere would be equal to 1 coulomb per second. Let's go ahead and take a look at some questions regarding current and voltage. So, for example, let's say you're asked to find the current. So calculate current, calculate the electrical current. If 1000 coulomb of charge passes through in 20 seconds. So here I'm using some very basic numbers in order to make the calculations easier. So I know that charge is 100,000 coulombs. The time is 20 seconds. I'm looking for the current. I know that I is Q over T. So I just have to divide the thousands by the 20 seconds. The zeros cancel out, and my answer is simply 50 amperes. And that would be the answer for this question. Now, if I were to do a question on the energy or the voltage, you could have something like this. So, how much energy, and let's make the numbers for this one is a bit, different, use some scientific notations. So how much energy is being carried by each microcoulomb of charge if it is connected to a 12-volt battery. All right, let's go down. Now, here, we're actually looking for the amount of energy carried by each coulomb of charge. So we're looking for the voltage, technically. We're not looking for the voltage, we're looking for the energy in their backpacks. So energy is simply going to be voltage multiplied by the charge. So V is 12 volts. That's the strength of the battery. And Q is, or the charge is about, it says each microcoulomb, so it's 1 microcoulomb. We know that micro actually stands for 10 to the power of negative 6. And we're supposed to calculate the energy. So energy is just going to be 1 microcoulomb, so 1 times 10 to the power of negative 6, times by the voltage, which is 12. So the energy carried by each of them is simply 12 microjoules, and that's a very small number because we're talking about a very small amount of charge. So let's go ahead and take a look at another type of question where it's a bit different. So let's say if a lamp is connected to a 12-volt battery for 5 seconds and a current of, let's say, 6 amperes is being produced, calculate the amount of energy converted in this 5 seconds. So calculate the amount of energy converted in this 5 seconds. So in this part, this is actually a two-part question. First, you got to calculate the, the voltage is given to you. It's 12 volts. You have the time taken, which is actually 5 seconds. We know the current is 6 amperes, and we're supposed to calculate the energy. Now, what exactly are we missing here? We don't have the charge. In order to calculate the charge, we have to use the equation I is equal to Q over T. Q is actually not given. So we can find Q by multiplying the current and time. So we can rearrange this and write Q is equal to, just put a denominator of 1 and cross multiply. You get 1 times Q, which is Q, T times I, which is just I times T. So multiply the current, which is 6, by the time, which is 5. 6 times 5 is 30 coulombs. Now that we have that, we just have to calculate the energy. Energy is simply the voltage multiplied by the charge. So 12 volts times by 30 coulombs, and the answer will simply be 30 times 12. And if you multiply 30 by 12, you can find the exact amount of energy that is being produced or converted in this 5 seconds, which is 360 joules. That's it. Thank you for watching, and study hard.